So out of the 6 objects that you have to find, 2 have to be light objects, which you can find in those things, or you can use your notebook, your pencil pouch. Some kids used their shoe yesterday. I mean, kids were like free. Somebody found their, mass weight of their AirPods and stuff. And you need to find 2 medium heavy objects, okay? Medium heavy could be like the cart that they put there. So medium heavy is anywhere up to 10 newtons. And then you need super heavy. Super heavy because otherwise we don't want all our data points to sit in one corner, and we also don't want all our data points to sit in another corner. We want the data points to be spread out. Does that make sense? So we want some weights in the 1 Newton, 2 Newton range, we want some in the 10 Newton range, we want some in the 20 Newton range. For the 20 Newton range, you can actually find the mass and weight of the total wheel balance itself. You can use this itself as an object, okay? And you can use this is very heavy, children, so you can use this also, okay? So all of these are available to you, and you can find the mass weight of your laptop bag without the laptop, of course. You don't want to drop your laptop.
Do you can leave your laptop?
If you have a hook to hang it, but don't drop it, because your parents will, not be happy about that. So what is our independent variable here? The variable that we are deciding, Elijah?
That's
We are deciding that we are going to pick 6 different objects of varying mass anywhere from 100 to 2000 grams, or 0.1 kg to 2 kg, which means what is our IV?
IV is
Kilograms, which is the mass, okay? So everybody, your IV is mass, okay? And which means what is going to be your dV, everybody, the whole class? The weight in newtons, okay? Which means when you draw the graph, what goes on your x-axis?
Mass.
The mass, awesome. What goes on your y-axis? The weight in newtons. So I'm going to draw a very simple graph, and in another 5 minutes we'll get started. So obviously the mass in kg goes on your x. The weight, which we can just represent it as Fg in newtons, goes on the y. And this is the 0. You do need a title. Okay, what is your title here? Everybody shout out. Or you can just say weight versus mass. And you're going to get a bunch of data points, and pretty much if we get proper measurements, should they all nicely line up?
Yeah.
And if they're a little bit off, that's okay, because what do? We draw a
Best fit
best fit line. So I'll get the best fit rulers out for you, which you don't need right now, and you will draw a best fit ruler, and the best fit ruler, best fit line has to go through 0, 0, because if anybody, when the mass is 0,
The weight is also.
the weight is also 0. Yes, Leo.
Did you draw the table?
Yeah, hold on a second, okay? And let me first explain all of the things you have to do, and then you can do that. So when you draw, you need to do all of that, and now we are going to find the slope, okay? When you find the slope, you're going to do this. Just like before, you're going to find a convenient point, and you're going to drop your rise. You need to show me your rise on your graph, everybody. Okay? And you do need to mark your rise here. Okay, what will be the unit for the rise? The rise will be in newtons. And you need to show me your run. Your run will be in? Kilograms. How do you calculate the slope? Rise over run. Okay? And can somebody tell me about how much should your slope come to? About here. Approximately?
About like 10.
Awesome, yeah. It should be about 10-ish. Which means if you get 8.5, that's okay. But you don't want to get 3 and say 3 is approximately equal to 10. It's not, right? So if you say 8.5 or 11, that's okay. okay, Newton per kg, right? Because we have
Closer to 9.8, right?
yeah, it's exactly 9.8, but if you get about 10, you're in a good shape. Is everybody clear? Yeah? So I'm gonna, oh, by the way, you also have to do a talking cloud, the cloud, and in the cloud you're gonna answer these questions, okay? So can I have Joyce read this question? So the slope is supposed to be about 10. Hopefully we'll all get it. What does that number tell you about the mass weight relationship? That's right. How many newtons are there in 1 kg? And let's do number 2. Number 2, let's go to Vivian.
Y value is 0 when x value is 0.
Uh-huh. Or why should our y-intercept be 0
Because
when the mass is 0 kg?
the force is also 0.
0 newtons. Absolutely. Okay? All right. So at this time, everybody, let me quickly show, first let me show you your groups and you can do your data table and all of that. And I'll tell you who is going where. Yeah. Okay, you're with Elijah's group, right? Okay, so did you guys, okay, still drawing your data table. Very good.
Is that the map? Yeah.
No, this, I measured it.
Wait, no, it was 300.
Hold it there. So this way we have empathy.
What did you guys get? What did you guys get?
608. No, I measured it on the triple beam balance.